State of the Union, November 2017. I've given this talk in a few different iterations over time. And so let's get into it. So brief outline of the talk is sort of how I got here. How did I end up doing a talk about spreadsheets with Python and why does one care? Then we're going to look at some of the fundamentals of a library that I'll be talking about. Well, the library I'll be talking about, Openpyxl. How many of you would consider yourself sort of new Python developers or novice developers? Okay, maybe. See some tenders, it's like maybe I am, but I'm not sure. And it's always a hard thing to know. Like, how new am I? Am I a beginner? Am I still a beginner? But I'm going to point out some of those fundamental differences because Openpyxl gives you some new data types that aren't built into Python. So I want to point some of those out. Those are important to working with spreadsheets. And then some of the basic things you can do with a spreadsheet once you've gotten its data into Python. And then this last point, some problems using spreadsheets by way of code. There are some unique difficulties that you run into as far as working with spreadsheets. So I want to cover those things. Again, I used to be an accountant, so I've spent I used to be a professional spreadsheet fighter. And so there are issues that you run into doing that. My secret origin, the sort of how did we get here, how did I get started with this? I'm adding a page to my blog, my secret origin page. The TLDR version is that when I came into the Python community to be a developer from being an accountant, one of my areas of focus was how can I make a contribution, and my approach is to try to grow the Python community by adding new contributors to it. And I feel one of the best ways to do that is to take non-programmers and help them become programmers by showing them ways that writing code can actually help them and be of benefit to them. And so that's one of the reasons for this talk. So who's the talk for? One, new developers, and that's why I sort of asked, how many of you consider yourselves to be beginners or newish to Python? But also people who end up using spreadsheets a lot and want to sort of take those spreadsheet skills to the next level or want to be able to do different things with those spreadsheets. I don't know what it's like here in Canada specifically, but I know that in the US, a tremendous amount of companies are basically run on spreadsheets, and people use them for everything. So if you find yourself having to fight with spreadsheets a lot, anything that you can do to make that process more effective and more efficient is beneficial. And of course, Python is the best language for that. We all agree. So then also, if you are a Python developer who keeps finding yourself confronted with spreadsheets, so maybe you're not an accountant, maybe you're not someone who uses spreadsheets on a day-to-day basis, but you're a more experienced Python developer, but you keep being given spreadsheets, and you keep having to do stuff with them. And maybe your approach has been, well, okay, convert it into a CSV and then do something with it. Well, that's one approach. This is a different approach that will give you some extra options. So that's sort of who I'm targeting with this talk. So now the code, we're going to jump into some code here in a second, but there are a couple of things here. The idea is for the code to be beginner-friendly, and the talk is beginner-friendly. It's almost a pseudo-tutorial. I'm actually working on a tutorial version of this talk to help new programmers learn some Python fundamentals, but also learn how to work with this library. The real key here is that any interesting code is going to be provided by your specific use case. And so I could have gone into a lot of complicated things. I could have done more things, but if that didn't matter to you, then you don't really care. So in this talk, I'm focusing on the basics of getting data out of the spreadsheet, doing some basic transformations just to sort of see what you can do, and then what you can do after you've done that. So once you pull data out of a spreadsheet file, what can you do with it in Python? So that's what I'm focusing on, but the real juicy stuff is going to be based on your individual use case. So step 0 in anything like this is you have to actually know your data. So now we're going to look at an actual spreadsheet, because if you're going to be processing a spreadsheet in some way, just like any other programming task, you have to actually know the data that you're working with. And so let's look at a spreadsheet. So this is actually based on a task that I did at an old job. And so I ended up with a lot of timesheet information. There's a sticker. I ended up with a lot of timesheet information. And so we would get these monthly data dumps. And in a lot of business settings, many business applications are really just relational databases with a graphical user interface on them. And they end up spitting out the results of their queries in these tables that line up very well with spreadsheets. And so we would get this timesheet dump. And so that's what this is to simulate. So here you have the amount of time that different employees for the company have worked in a month. So you've got the employee number here is the first cell, in the top left, the employee number that identifies the employee, the cost center that employee worked for, so it's sort of their subdivision within the company. Next, you've got their division, which is a larger division. So cost centers are inside of divisions. And so you might have, say, here, Division 1000, that might be the North American division. And then Division 2000 might be the European division. So you can have cost centers inside of divisions. Next, you have the manager. Who is that employee's manager? And I've got you sort of, fictional random character names here. Those aren't real people. And then the date work. So what was the day that that employee worked in the month? And so these are all months in June of 2017. Then the employee's name. And I've simplified this. I don't have first name, last name. In a real data dump, you'd have like a first name and a last name. Here, I just have some random string of characters. And then how many hours did that employee work on that day? And then here we have project. In a lot of professional services firms, if you're working for an accounting firm or an engineering firm or something like that, there's this concept of whether you are on a project or off a project. And so companies want to know about that sort of thing for utilization purposes. So if you have an employee, do they spend 90% of their time on a project that you can bill their time to? Or did they spend 80% of the time, that sort of thing? And so this column is about were you working on a project or not. In this example, it doesn't really get used. It's sort of a remnant of an older version. So this is the data that we have. And again, you need to know what your data is. What we're trying to do with this data is we have all this data, again, for the course of a month. We got about 1,000 rows of data here. But you'll notice we have data from different days. What we want to do is we want to aggregate this so that we know for each employee how much time did that employee work in the month. And if we were using the project column, we could even break this up so we could see for each employee how much time did they spend working on a project and how much time did they spend working not on a project. I've simplified the example here, so we're just going to assume everyone's working on a project, but that's what we want. We want to know for every employee how much time did you work in this month, and then we can do other things with that later. So that's the data, and that's the problem we're trying to solve. So how do we go about doing that? And so now we get to the code, because programming is problem solving. So how do we go about doing that? So let me close that. So the first thing we're going to do is, and again, if you're new with Python, we're going to import this library, Openpyxl. Openpyxl is the library that I'm using. Let me go quickly to the docs page there. So Openpyxl is a library that you can use to read from and write to XLSX files, which are the newer format for Excel, the spreadsheet Excel. But these files can also be opened and used in LibreOffice or OpenOffice. So when I showed you all the spreadsheet, it's an XLSX file, but I'm actually using LibreOffice, not Microsoft Excel itself. And so you can read from and write to these files. There's a lot of data you can get from these files with this library. So that's the library I'm using. So we're going to open it, we're going to import it, and then from Openpyxl, we're going to import workbook. And this is where we get into some specifics about terminology. Here you'll see on line 8, I've got WB to WS to cell. Workbook, worksheet, cell. People often use the term spreadsheet just sort of in general as this generic word, but more specifically, an XLSX file is called a workbook. And then within that workbook, you have tabs. We take a look here. You might not be able to see, but at the bottom there are different tabs. Each tab is a sheet. And so those are called worksheets. And then each worksheet is made up of cells. So I don't point that out just for the sake of being pedantic. I point it out because when you look at Openpyxl, it gives you data structures that are that use those names. And so here we're importing on line 2, importing workbook. And then on line 6, I'm creating this object that I call WB for workbook, openpyxl.load workbook, and then I give it the name of the file. And the file I'm using here it's the demo file for PyCon Canada. And so I'm creating this workbook object in memory. And so this is a new data type that the library provides. This data only equals true flag that I'm using here is interesting because if you're familiar with spreadsheets, you'll have a spreadsheet and there will be formulas in the spreadsheet that will create the values. With data only, this is telling it to only capture the results of those formulas, not the actual formulas themselves. And so in this case, we want the results of the formulas. We don't want the actual formulas. We just want the results. So data only true is capturing that for us. And so what that's going to do is basically give us the data that's in that spreadsheet. And then from that workbook, I'm creating this demo worksheet. That's what we'll actually be using. And the worksheet, I'm doing workbook.getSheetByName. So this is a function that's provided by Openpyxl. So I can tell it the name of a specific cell, of a specific worksheet, I'm sorry. So when you see the tabs along the bottom of a worksheet, or of a workbook, each tab is a specific worksheet and they have names. So I can grab that worksheet by its name. So I just want that specific worksheet. And so that's going to be my demo worksheet. And so now I have that demo worksheet, I can actually get to work on it. Move that because I was lazy. So now I've got that worksheet. So what I want to do first is I'm going to take those employee IDs, and if we look at the original spreadsheet, there's a lot of repetition because for each employee, so for instance, here's this employee, and here's the time they worked on the 12th, same employee number, here's time they worked on the 13th. And so I don't want all those duplicate employee numbers, I just want a list of, okay, how many employees do I have? So I'm making a set comprehension here. And if you're not familiar with comprehensions, they're a way for you to iterate over things. I don't really have time to talk about the differences between comprehensions and for loops. This is the same code done with a for loop. But if you have questions about those distinctions, I can talk to you about those afterwards. So here, I'm making a set comprehension, so I'm saying, I want the row 0 dot value, and so here, for every row in demo worksheet dot row, so we made that demo worksheets object before, which was a worksheet. Demo worksheet dot rows in Openpyxl, that's going to return a generator object, and that generator object is going to give you a tuple of values for each row. And so I want row 0 from that row, so that's going to be, so each row is going to be one row in the spreadsheet. I want row index 0, which is going to be the first value, so I want the employee number. But here I want dot value, and then this is where you get into the distinction between worksheets and cells. So row index 0 is going to be a particular cell, but there are a lot of things you can get from a cell. And so this is where you have the advantage of using Openpyxl as opposed to just converting something to a CSV. You convert something to a CSV, you just get that raw, you just get just the plain data. Here, this row 0 construct, row index 0, represents a cell. There's a lot of different information you can get about a cell. You can find out what font is being used. You can find out what color is in the cell, the background color, the color of the font, all sorts of other information. But you can also get just the value that's in that cell. So that's what I'm doing here. So row index 0 represents a cell, dot value. So I'm getting the value from that cell. So I want that value for every row in demo worksheet.rows that's coming out of this generator object if that value doesn't equal employee number. So this is just a simple way for me to skip over just that header row. And so as long as that value is an employee num, then give me that employee number, give me that value. And since I've got the curly braces here, it's going into a set. And I'm using a set because if you're not familiar, a set in Python is a built-in data type where every value is unique. And so you won't have any duplicates. And so I'm doing that so that I can build this list of employee IDs that doesn't have any duplicates. So now that I've done that, close some of these to minimize my clutter. Now that I've done that, I want to create a dictionary of each employee and their information for the month, like I talked about before. So I've got now my list of unique employees. What did they do for the month? So I'm calling that an employee aggregate. That's what this dictionary is going to be. And then, so for each employee in employee IDs, here I'm using, again, another comprehension. Well, actually, a series of comprehensions. So for every employee in that employee IDs group set that I built, I want to get the hours for that employee, and so I'm making this list comprehension. And so here I'm making a list comprehension because I do want duplication. I want a list of all the hours that those employees have worked, and I'm going to sum those up at the end. So I'm just doing this list comprehension. Here I've got it broken out for readability. So this list comprehension, so I want row index 6 dot value, and index 6, that's where the hours are stored in the spreadsheet. So I want the row index 6 value for every row in that demo worksheet.rows, a generator object that we saw before, if employee, which is the employee number, equals the row index 0 value. So for each employee in employee IDs, I want to look through and see, okay, if the employee number in that row is the same as the employee that I'm looking at, give me their hours. And so I'm going to build up this list of all the hours that match that employee. And then I'm going to do the same thing for the different bits, but in all the other cases, I'm doing set comprehensions. For the cost center for that employee, for the division for that employee, and the manager for that employee, because each employee should only have one cost center, one division, and one manager. So I'm using set comprehensions here. I haven't broken those out for legibility, but it's the same process as with the list comprehension. And so here, one of the things I do in my current job, I do QA in my current job, and I was a financial auditor before that, so I try to check things and make sure they're right. So I've just got some assertions here. Like I said, every employee should only have one cost center, one division, and one manager. So that construct that I'm building, the cost center, the division, and the manager construct should all have a length of 1, because there should only be 1. So I've just got an assertion here in line 18 to make sure that that's true, make sure I haven't done something wrong. And now that I've done that, I've got this employee aggregate. I made the empty construct here, and now I'm just adding that dictionary, adding the values to that dictionary. So the key is going to be the individual employee ID, and then I'm just adding in, I'm summing the hours, and then I'm adding in those lists for a cost center, division, and manager. So that's going to give me this dictionary of the aggregated employee values. So so what I've done now is I've taken this spreadsheet and I've now pulled the data into Python. Then I've built a Python data structure that has that data. So now what do I want to do with it? In this case, the next thing I'm going to do is I'm going to write that aggregated output to another spreadsheet. Depending on your business context or your work situation, you might get spreadsheets as input, and then you might be required to provide someone else's spreadsheet as output. And so here, after I've done this processing, I'm going to provide it I'm going to provide the output as a spreadsheet, so I can then pass that spreadsheet on to someone else who wants it or needs it. And so for that, I'll create this output workbook construct. So output book equals workbook, and so I'm creating this workbook in memory. And then within that workbook, you need to create a specific worksheet for that data to go to. You can't just write it to the workbook itself. So the output sheet is, I'm just creating the sheet. Here, I'm giving it a name, aggregate time, and then this 0 value at the end is telling me where to place it. And so by default, it will put it at the end, but I can here, by saying 0, this is going to make it the first sheet in the workbook. So you can sort of place it wherever you want. And then here, I'm doing 2 things here. One, I'm just building a header for that output worksheet, but I'm also demonstrating here that you can select a specific cell. So for instance, the demo worksheet, A1, the A1 value in our worksheet, if you recall, is going to be employee name. So A1, B1, C1, those are just those top values. And I do that it's a simple way to make the header, but also to point out that one approach I used to pull data out of the spreadsheet was by pulling out entire rows at a time. If you need to pick specific data out of a spreadsheet, you can say, okay, go to that worksheet, go to this specific cell, and grab that value, or you can write the value to a certain specific cell. So I'm just sort of doing that also as a demonstration here. So give me the value from cell A1, give me the value from cell B1. So that's how I build the header for my output spreadsheet. Then I'm creating this data structure that I'm going to use to output to the spreadsheet object, and then I'm appending the header to it. And then I'm adding these new rows to that output object. And so for every employee in that employee aggregate dictionary that I created, I'm making a new row, and then I'm appending the employee ID, and then to that employee ID, the cost center, the division, the manager, and the hours keyed for that specific employee. And then with that new row, I'm appending it to this output data construct that I've built. So again, these are all, most of this is sort of fairly standard Python. Here, you've got something that's specific to Openpyxl, that's grabbing a specific value from these objects. So you've got a mix of standard Python processing along with some things that are unique to Openpyxl. So now that I've created, what I have now is I now have this sort of full spreadsheet object, but it's in memory. Well, actually, not quite. I have what will go into the full spreadsheet object. So now I have this data structure that mimics the spreadsheet object. So here, I'm actually writing that data to the spreadsheet object. So in line 2, I'm going through, so for every row in that output data construct that I just built, and then here's where things get a little tricky. One, I'm going to get the index for that row. So output data.index, and this is a built-in Python function to get the index for that row. So, and then for every column that's in this range, that is the length of output data 0, which is that output data construct. So for every row and then for every column, I'm going to the output sheet that I made earlier, then dot cell. And so again, this is another Openpyxl data construct. So I'm going to a cell in that worksheet. But then the question is, which cell do I want to write to in the worksheet? And here, I'm giving it a specific row and a specific column. The trick here is that when I do this indexing, Python indexes things starting at 0, but spreadsheets start counting at 1. And so here, I'm having to take this row index and add 1 to it, because Python would give me a 0 here. But the spreadsheet, the spreadsheet starts at row 1 and column 1. So I'm adding 1 to this row index, and then I'm also adding 1 to this column value that I got. So for every column in, and again, I'm not pulling an actual column, I'm just pulling numbers from a range, but again, Python starts at 0 instead of 1. So here I'm saying, I'm programmatically creating the row number and the column number for that specific cell. So that tells it where to write into the cell. And then, so given that cell, I'm saying dot value. So I'm setting that value to the output data in that row index in that column. And so there's that little tricky thing there because, again, spreadsheets start counting from 1, but Python starts counting from 0. So this is going to take that output data construct and write its data to this worksheet object, to the output sheet. And so now I have in memory a workbook with a worksheet in it that has the data that I want in it. I still don't have a spreadsheet until line 9, however, and this is the important part because you can't send anybody anything until you've done this. So line 9, you do this output, you save it and give it a file name, and now you actually have a spreadsheet. So let me go here, and so just run this, run that, run that, run that. I think that is the step that takes the longest, usually. And I should have just run these all in total. And so now what we end up with is, oh, there we go. That's a little too big to read. This done PyCon.xlss file. And so now we have this new file that has the aggregated data for all those employees. As a final step, if you want to use this data for some other purpose to configure something, you can look at config.json. You can turn that object into a JSON object. And so here, I've just done this import at the end. Actually, this is a little more legible here. So I've done this import JSON here, and then I'm opening this file that I'm calling aggregatetime.json, and then I'm dumping that employee aggregate dictionary that I made earlier. And I've just sorted the keys and indented it so it looks a little nicer. And so that was the last step. And so I've taken that object and I've dumped it out here. So now I have this JSON object. And this is sort of what it looks like. And so you can use this for whatever other purposes you might have. If you needed to configure some sort of an application, you can do that. If you wanted to do other work with this, and again, if you wanted to arrange this in a different fashion, here I have this arranged by individual employees. So for each employee, I have what call center they worked in, what division, how many hours they worked. If I wanted instead to have this arranged by, say, division, and I wanted for each division, then within each division, I wanted each cost center, and then within each cost center, how many employees do I have? You can do that too, but there are different options. The processing, the specifics are up to you. So those are the basics. Demo. The demo brought to you by Jupyter Notebooks because they're awesome. So those are sort of the basics of pulling data in from a spreadsheet, processing it, and writing it out to a spreadsheet. If all the spreadsheets that you ever get have data that is structured in that fashion, just is structured in tables like that, you probably won't have many problems. The real issues that you run into when you work with spreadsheets is that spreadsheets are often used as a visual medium. And so people design spreadsheets to look nice. They don't design them necessarily to have structure to the data. Or the structure that the data has is structure that only makes sense if it's being read by a human and being parsed by human eyes. And so those are some of the issues you'll run into. Fortunately, OpenPyXL has the thing, and this is where OpenPyXL becomes a stronger option than just turning a spreadsheet into a CSV file. You can look at those cell values, and so, and maybe you only want the values that are in red, or you want the values that are negative numbers, or you want the values, if someone has done conditional formatting on a spreadsheet because their boss likes to see a spreadsheet that looks that way, you can look for certain cell attributes. And if you create a cell object with OpenPyXL and then just use the dir command, the dir statement from Python, you'll see all the different attributes that exist that you can look for in a cell. And so there are a lot of different things that you can do. You'll often get, like I said, this sort of unstructured input data. So you'll have problems with spreadsheets as these visual input medium, but also you might have some visual output requirements. Somebody needs some sort of a report to look a certain way. You can apply different styles to cells with OpenPyXL. So when you write the data out, when I wrote the data out, I just wrote it out in a very plain fashion. But you can write it out with different sort of styling requirements and that sort of thing. So there's a lot you can do. So if you have a Python program that you're already running, and then you need to give that output to somebody in the form of a spreadsheet, you can style it in a certain way that looks nice to them. Last thing is making new friends. Again, if you're trying to sort of grow the community, depending on who you work with and where you work, you might find opportunities to help create a new Pythonista by showing them, hey, you know what, with just a little bit of code, you can automate this process. That process that I just showed you came from me having to work on something that used to involve like 6 to 8 hours of manually copying and pasting. And then I wrote 2 scripts that did the whole thing in about 90 seconds. And so, from 8 hours to 90 seconds, people will like that. They might be willing to standardize their data and make some changes if it will give them this tremendous time savings. And also, like I said, you can use the cell styles to let them recreate the sort of visual things that they need to do. I've actually done that in some cases so that I could have this report print out and look at exactly the same way it did before, but without all the copying and pasting. So that is the talk. If you have any questions or comments, again, I am Transition on Twitter. My website is here, and then the code and the slides for this are going to be on my GitHub. So if are we out of time? We have a couple?
Yeah, we have. So first of all, thank you so much, Kojo, for showing us. Getting out of spreadsheet hell is always appreciated.
That's
Thank
true.
you. So we have time for a couple of questions. You were first, I think.
What about character encoding problems? If you've got a spreadsheet from Microsoft and you need to convert characters into either UTF-8 or HTML character entities or something like that, I think I've had problems.
Yeah. Let's see. I'm trying to remember. I think you can bring those values in, because so now character encoding issues I haven't worked with specifically. I think OpenPyXL defaults to UTF-8, but I honestly can't recall. But if that's sort of like a general thing you're aware of, then you can build that into how you read the data in, so and make sure that you're looking for certain things.
You have to do it in Python rather than in the library. There isn't a specific request in OpenPyXL for encoding the data as it comes out. You have to actually use Python encoding.
I'm honestly not sure. Yeah, I know, for instance, so I know it does certain things automatically. So like if there's like a date or a time, it will bring that in as like a Python date time object. But with character encoding, I'm honestly not sure. That's something I need to check out though.
Okay. In the back. Blue shirt. Yeah.
From your personal experience, how fast is it compared to pandas?
Honestly, I haven't used it in that way. So, so when I built the project, I ended up using this as opposed to pandas. I think the difference with pandas is pandas works well for well-structured data. And this can be used for well-structured data, but this can also be used for badly structured data. And so, and I think that's one of the things I like about this as opposed to pandas. But yeah, so honestly, I haven't done a head-to-head comparison, so I couldn't say.
Do you have more material or tutorial on how we
Okay, so the question was, do you have more tutorials?
I'm actually kind of working on some of that stuff. However, the OpenPyXL documentation is excellent, and so especially depending on what you're looking for. So, like the question earlier about encoding styles, that sort of thing. The documentation here is really very impressive. So I would say sort of start here and try to look for any specific things.
For example, building data model, creating different linking formula, and you know what I'm talking about when we're talking about natural.
Yeah, so OpenPyXL isn't the best thing for creating a more advanced spreadsheet. It's more for taking data out of a spreadsheet, and then the more advanced things that you would do those in Python, and then you would maybe output your results to a spreadsheet. I think there's a library called Excel Wings that will let you build more advanced functionality into a spreadsheet. But with OpenPyXL, the idea is get the data out of the spreadsheet and then use all of Python's facilities to do all the advanced processing you want. And then if you need results in a spreadsheet, write them back.
Okay, so thank you very much. We're out of time,
Okay.
but
I'm
Yeah.
large and my head is shiny, and so you should be able to find me, or just find me on the internet as Transition. So thank you for your time.
so thank you so much, Kojo. Now we have it.